Welcome to lecture 30 of the course CS213 Object Oriented Programming of the Cohort University of Science and Technology. In this lecture, we will continue our discussion of the Java database connectivity, and our focus will be on SQL or SQL statements. So as we understand that what is basically SQL, it is made of these different languages, if we say, or different statements that allows us to create relations or attributes, allows us to manipulate data in our tables or relations, allows us to control the privileges that we can have with regards to the data in our tables or databases, and allows us to query our database or select data from our databases. We have create statement to create data in our database. In our previous lecture, we saw that we can create tables using the interface of the DBMS, but we can have a create table statement that asks us for name of the table, then the columns, the data type of the column, and the constraint that we can have on the column, one or two, or however many columns we need, and that we need is the name of the column, the type of the column, and the constraints that we want to have, like the primary key or the unique or the null or the not null constraints. And this is all we need to create a database. Column is the name for the column, the type is the column's data type, and constraint are an optional constraint on the column. Data types can be, as we saw, character or char, and with a length. Varchar with a length is strings of maximum length len. So we provide the length in these parentheses. We can have float or real. These are for approximate numbers. We can have int or integer for exact integers. We can have decimal or DC for exact decimals. We can have date, time, or timestamp for timestamp combines date and time. We can have constraints like not null, no missing data will be allowed in the column. Unique, every value is unique or missing. Primary key, every value is unique, plus other more sophisticated predicates that we'll briefly look into. An example of a query can be create table students. SID is the name of the column, int is the data type, and it is a primary key. Name may be the name of the student, varchar is the size of, and the data type of the column. Varchar is the data type of the column, and 50 is the size or the initial size of the column, and not null is the constraint that we put on this column. And then we have a date of birth column with the type date, and this will create a table with these three columns in our database, as we saw in our previous lecture. Then we can insert values into our database. For example, insert into the name of the table, column A, column B. Then we have the values, value A, value B, and maybe optional column. If we want to provide the column's name, we can, or we can directly provide the values for the column in the order of the columns in the table. If no column names are given, the order in the create statement is used. An example of an insert statement can be insert into students values 0 Peter Mark. Now in this case we are not providing the names of the columns, so we can directly insert values into the columns, but in the order in which we have created the columns in our table. Since no columns names were specified, 001 is the student ID or SID, Peter Mark is the S name or student name. Now we have not provided the value for the date over here. Null, and for that a null will be used. So in this case 1 is stored for the SID, Peter Mark is used for the S name, and null is used for the student's date of birth. We can also delete values from our database. Delete from the name of the table, where predicate we provide a condition. Deletes all tuples from table that match predicate. Predicate will be the condition that we want to match, or a particular column that we want to delete. Search out from the table and delete, and this will delete a row from the table. Use a primary key to isolate the one tuple. Example is delete from students, where the ID of the student is 1. So we need to search for the student, and that will be for this predicate statement. Through this predicate statement, where the where is class in SQL, we can use this. You can say it's a keyword in the SQL. Delete or from, these are the keywords in the SQL, and then we can use this to search a particular student. For example, you want to search a student with the registration name to, and you want to delete that student. You can select the results from the tables. As we saw, select the attribute list from the table or table list where there is a predicate list. So if you want to select a certain condition, then you can provide that in the predicate list or with the where clause. Logically computes cross product of all tables, so you can select data from multiple tables if you need. Discards results that don't match predicate, so it will retrieve, the first statement will retrieve data from all the tables, then the matching data will be returned to us. So a simple example will be select S name from students where the date of birth is greater than maybe 1995 or 1975 if we do not have this data in the table. So this retrieves all students born since 1995. Select class, and attributes list is either indicating all columns, a list of unique attributes names. Usually an attribute name will suffice, so we provide the name of the column. If you are not, asterisk is used for selecting all the columns. If you are selecting all the columns from your database, you use the asterisk. This will select all the columns from the table. But if you are selecting unique tables from unique columns from your database, then you can use the names of the columns. Sometimes we need to provide the name of the table with the column name. Can rename attributes using as, so you can use the as keyword to shorten the name of your or simplify the name of your column maybe. So if you want to select the SID from the students table, then you can use select students.sid as ID. So you can now use this ID as the column name in your SQL statement. S name grades, this is another table maybe that has a grade of the student. Then the from class, it is a table list is a list of unique table names. So from class is followed by the names of the tables that we want to select the data from. Usually table name will suffice, so you provide the name of the table. Multiple occurrences of the same table must be renamed using as. So if you have multiple tables in different databases, then you can use the as keyword to differentiate those tables. So if you want to rename the final grades as grades, this will give an alias or a temporary name to your table that you can use within this SQL statement. Then there is the where clause. The predicate list contains join predicates, where we can join different tables which relate to columns from different tables or different columns of the tables. Then we have select predicates which relate a column to a constant or another column in the same table. For example, if you want to select data from two different tables with the same where some data is similar, where we are connecting the two through some value. For example, where class where the grade is greater than 3 and student's ID is equal to the student's ID in the students table is equal to the student ID in the grades table. So we have stored the grades of the students in the grades table with the student ID, and then we have the students original IDs and the names of the students in the students tables. So this is how we can break up our data into different tables, and then we can connect those tables using our SQL queries. So this is the full statement as we can see over here. So we want to select student ID from the students class as ID, the name of the student, the grade of the students from the students table, from the grades table, that is the final grades table, that is will be renamed as grade, where the name the grade of the student is greater than 3, and the ID of the students in the students table matches the ID of the students in the grades table. Now this grades tables, as we can see, is the final grades tables, but that is renamed to the grades table. Now we can use this grades name within this SQL statement. This is the tables that we want to return the data from. This is the students table, and this one is the grades tables. We have the students ID over here, the names of the students and the date of birth. We have the students ID over here, the courses and the grades for those courses in this table. Now when we run that query, initially the cross products of these tables will be returned. It will return all the data from the students table and all the data from the grades table. In next step, it do is it will match the student's ID as we after reading the where class. It will match the student's ID with the grades ID, where the student's ID in the students table does not match with the student's ID in the grades table. It will cross out those results so that we have the grades for the students that we want to look for. For example, we cannot have the grade for student ID 1 with the ls. For example, the name of the student is ls, that is student ID 1, and here the grades are of students ID 2. So the not the columns of not matching results will be discarded, and the final result will be returned to us. And this is how our SQL queries work. The mismatching results are discarded using the where class, and the matching results are returned to us. Now this condition was also checked where the grades are greater than 3 and where the student ID in the students table was matching the student's ID in the grades table, and those results were returned to us. We can also use SQL statements for grouping and aggregation. For example, we can use the group by keyword. Aggregation functions like count, sum, and average can be used in our SQL statements, and there can be more sophisticated predicates, but here we won't go into those details. We will have a look at some of the SQL statements in our programming example, but we will leave the extreme details of SQL and the database to the dedicated database courses that we'll have in the upcoming semesters. Maybe we'll conclude our discussion of the SQL statements over here. Now let's look at the same example as we saw in our previous class, but with a graphical user interface. Now here we attach or link our database to a graphical user interface, and we would be able to go through the database, see the contents of the database on this form. So what you need to do is to load a form, as you may have practiced for your graphical user interfaces, and add buttons. So I have added 3 panels to this JFrame form, and I have added these different buttons and these different text fields to the form. And then what we do is we add code on the back end of each button. So when the button is clicked, a particular action is performed. So if I run this, and the kind of output that I'm expecting is that it will pick the first row from our table, and it will display the data in these text fields. So this is how I would pick the data from the database and would set the values of the columns into my text fields and display those columns in this text field. Now what I want is for these buttons to respond to a certain code. So if I click on next, I should be able to go to the next record, and when there is no record, I should get a message of end of file. Similarly, if I click on the first, I should go back to the first record. If I click on the previous, I should get back to the previous record, or I should get this message. If I click on the last, I should get to the last record. If that is the last record, I should ideally get a message. If it's not, I should go to be able to go to the previous record using clicking the previous button. With the delete button, I should be able to delete data from my table, and with the add new button, I should be able to insert data into my table, and with the update button, I should be able to update a record in my table. There are two buttons, as you can see. These buttons are blurred, these are inactive, and these buttons become active when I click on the update button or when I click on the add new button. So when I click on the add new button, what happens is that a new empty record is created, a new empty form is created, and when I add data into these text fields, what should happen is when I click on the save button, that data should be saved or inserted in my table. If I click on the cancel button, then I should go back to my form, and update should be working as record updated. If I need to change something in my record, and the delete should delete a record from my table. So this is how this interface is supposed to work. Now going back to the program, let's have a look at this program over here. So you have the design of the program, and then you have the source code. Once you create the form, you understand that this class will be created as the backend code for your form. If you have worked with the graphical user interfaces or created a program in there, this will be created for you. And here is the constructor of this class. This is already there. This is the function that calls the initialize the components, and we have added another method that when this method is called and a connection to the database is established, you can directly connect to the database within this constructor as well. So what happens is, as soon as you run the program and the form is loaded, the connection will be established to your database, or you can create a separate function for it, method for it, that will be called, and the connection will be established. As we understand that we need to import the required classes and interfaces for our connection to the database. We import the required details, and these 5 will be required at least. And then we have a option pane that will be used for displaying a message on our graphical user interface. We have objects of these interfaces and classes. So we have an object of the connection class, we have an object of the statement class, we have an object of the result set class. We understand that these are global variables in the sense that these are declared outside of this method, so we can access them in all of the methods inside this class. And then there is a variable initialized to 0, that is the current row. This will show us the current row in our table. We establish the connection using the same details, the same method. So we establish the connection to the books database, the username, the password. You copied this address from your database, and we make sure that the server is running and the connection is established. You pass these details to the get connection method of the driver manager class, and then you run the create statement method and store the result in the statement. Now, to be able to update your table, we need to provide these details as well. To be able to scroll through the data, type scroll insensitive. These are constant variables of the result set. You need to pass these to the create a statement, otherwise you won't be able to scroll through the data through the result set, or be able to update your data in the result set. So make sure you have set these properties as these are over here. Then there is the select statement that we saw previously, and when we execute the query using the statement object, the result will be stored in the rs object. Now here the first thing what should happen is, if there is any record in the rs, that will be checked through the next method. The first value should be stored in a local variable. So what we do is, for example, we are getting the integer value. Since now we will be displaying our values from the database in text fields, and we understand that our text fields can only display data in the string format. So what we are doing over here is, in this line we are getting the data from the first column of our database or the table. We are converting it to the string format, and we are storing it in a local variable in the form of data type string. Rest of the values or the columns were of type string, so we are directly getting them through the get string method, and we are storing them over here. We can get our columns through the column names as well. So we'll need to provide the names of our columns over here, or we can get the columns through their index numbers as well. This will initialize our text fields to the first column or the first row of the table. So text.txt id will have the other id in its first, that is our first txt id, and this will, as soon as we run the code, the details of the first row are displayed in our text field by default, and the other text fields will be, or the other data are displayed in our text field as soon as we go on clicking our buttons, and we will add the functionalities for those buttons to go through our database. So what we should do next is, now when we run the program, the details of the first row will be displayed in our text fields, and then you will click on these buttons one by one. So when you click on the first button, get button first action performed, if you remember this, it will take you to this method. The result set class has a few methods that checks the data for you in the table. So if you click on the first on the button, then it checks if there is the first record in the table, then it initializes or assigns those record the values in that record to our local variables, and then displays those values in our text fields using the set text method of the text field. And you click on the next button, for example. So if it checks if there is a next record in the table using the if statement, and if there is the next record in the table, what it should do is it will read the values from that record in our local variables and set our text fields to those values using the set methods. If there is no next record, then the value is set to the previous, the result set is set to the previous record using the by calling the previous method, and we will display a message on the screen like end of file. This is the end of file. Similarly, we can click on the button sidebar 1. This same is for the previous button. If there is any previous record, that will be assigned to a local variables and displayed on the text fields. Otherwise, the message will be displayed on the screen. And for the last buttons, there is if there is, that is the last record, you click on the button. If that is the last record, then it will be read through to our local variables and displayed on the screen. Similarly, if we go to the code for the add new button, then what should do is it should to go to the end of the table first, and that is done by setting the current row to the rs.getRow, and the rs.getRow will set the rs to the last record or the first empty record in our table. If there is any error, then that will be logged and exception will be handled. And what it needs to do is it needs to empty the text field. That is all we are doing with the add new button. And what we are doing next is we are disabling the buttons that we are using to traverse through the table. So the btn first will be disabled, and that is done by setting the set enabled method to false. Btn next, btn previous, these buttons are disabled, and the two buttons that were disabled initially are enabled. And this is all what we are doing when we click on the add new button. So we have enabled the button save and the btn cancel, and we have disabled the other buttons on our screen. We have emptied the text fields, and we have set the current row to the first empty row in the database. And next when we click, once we have added the record, we click on the save button, and most of the functionality will be performed on the save button now. What happens on the save button is we will read the data from the text fields on our screen. So we read the first name by using the getText method of the text field into a variable. We read the last name into a variable by using the getText method. We read the title of the book, and now we need to convert the txt format or the text form of our text field id into an integer, since our database is storing data in integer format. So we'll need to convert that into an int in order to be able to insert that data into our table. Then we call the move to insert row method of the arrest object that will move our cursor to the insertion row, that is the empty row or the last row in our table. And what we do in that row is we update the columns in that table. So we update the column id to the new id variable. We update the first name column. Now as I said that we can use the names of the column or we can use the index numbers of the column. For the integer value we use update int method of the rs object, and for the string values we use the update string method of the rs object, and we put those values into our columns of the table. Now once we have updated all of these records, we call the insert row method. What we need to do is we need to refresh our connection to the database to be able to insert that record in the database, and that is done by closing the database. That is by closing the statement object and by closing the rs object and calling the connectDB method again. This will refresh the connection to our database, and that is when we will be able to see the new record in our database. Otherwise, if you do not do this, if you do not refresh the connection, you won't be able to see the new record in your table. And the next thing is, once we have saved all the data, we enable the first button, the next button, the previous, last, update, delete, and add new buttons, and we disable the save and cancel button. If we click on the cancel button while we are adding the data, we get back to the row where we were previously. So that is done through the absolute method of the rs object, and we are back to the current row where whatever the current row at that moment would be. And we read the data from our text fields into our local variables and set those as the values of our or the data within our text fields. Now we are doing this without assigning to our local variables. We are doing this directly, so we can avoid repeating that code, or we can reduce our code if you want to do this directly. So in this line what we are doing here, we are reading the data from the column, the id column, that is an integer, so we are using the int get int method of the rs object. We are converting it into a string and we are displaying it in the txt id text field by calling the set text method. So all of that operation is now being performed in one line, and we enable the buttons that were disabled and we disable the buttons that were enabled. And finally, when we click on the delete button, btn delete action performed method will be called, and it is done simply by using the delete row method of the rs object, and we need to refresh the connection again as we did for when we updated the record, or when we added a new record to our table. So we need to re-establish or refresh the connection by closing the already open connection and statements, and by calling the connectDB method again. And also we can look into our update button. If I remember, the update button simply updates the record, so it reads the current details. So if we have made any changes to our record, then those records will be read into our local variables and then will be updated in the database. So we do not need to reestablish the connection since we can have access. We are not adding any other row to the table, we are just updating the current table. So we can simply call the update row method on the rs object and the record will be updated. Now let's run this code again and try to add some record to our database and try to make some changes, and we'll see how we can manipulate our database from our interface. So this is the database that we are interacting with, and let me add a new record to the database. So if I add maybe 105, my book, and if I save this, new record added. Let's try to go through this. 1, 2, 3, 4. As you can see, the new record, we can see the new record over here. We need to look for this record in our table now, and as you can see, we have added this record to the table from our Java application. And let's now try to maybe update this by making some changes. Maybe I want to change my name to Khan and the title of the book, and then we will try to see if we are able to update the record. Now I can not see over here. We need to refresh this, and as you can see, the record has been updated over here. Now let me try to delete this record from the table. So I can go through this. I can go through to the last, and I delete the record. So it is telling me the record has been deleted. And as you can see, it has gone to the first record. If I refresh this over here, you can see the record has gone. So the record from my database has gone. So we are able to connect and manipulate our database through a Java application.